Okay, plan for this recording is to talk through domain and range. Domain and range is a concept that a lot of people struggle with, so I decided to do a separate recording just on domain and range. Domain, as we talked about in other recordings, the domain is a set of all first coordinates when you're looking at a relation or a function. Another way of saying it, it's the domain or the set of all inputs. Another way of saying it is that it's the set of all independent variables. All those definitions mean the same thing, depending upon what we're looking at. If we're looking at an xy coordinate, it's the first coordinate. If we're looking at some real-life function or some real-life experiment where we have an independent variable, something we're controlling, and we have a dependent variable, something that results from the experiment we're doing, then the domain is the independent variables, the first coordinate, the x-coordinate, and all that. All those different ways of saying that is the same thing. All right, range, set of all second coordinates, or the set of all outputs, the set of all dependent variables. That's my range. So these first things we've talked about before, but let's just kind of talk through it again. See what you know, find the domain and range of that, and decide whether or not that's a function. So let's call this question 1, question 2. So question 1, decide whether question 1 is a function. Decide whether the set given in question 1 is a function, and then write its domain and range. Hit pause, hit play when you're ready to go again. Domain. Let's use set notation. I think some books call it roster notation. Set notation. So my domain, set of all first coordinates, 2, 3, and I don't need to write the number 2 again. So my domain is 2 and 3. Range, set of all second coordinates. So 4, 9, and 5. My domain, set of all first coordinates. My range, the set of all second coordinates. Okay? This one is not a function. The number 2 goes to 2 different outputs. For every input, there is not only one output. In this case, the number 2 has 2 different outputs, not a function. Okay, question 2, same question. State the domain and range, decide whether or not it's a function. Domain 1, 2, and 3. Range 3, 4, and 9. It is a function. For every input, it matches up with exactly one output. The 1 goes to a 3, the 2 goes to a 4, the 4 goes to a 9. Up here, doing the same pattern, 2 goes to a 4, 3 goes to a 9, and the 2 also goes over here to the 5. Okay? All right, that should have been a little bit of review. Let's try a graph. Here's where people seem to have a harder time. What is the domain and range of that graph? And let's assume that's it. There's no arrows on the end of those lines. That is all there is. That is the entire graph. That's the entire function. What's the domain and range of that? Remember my first slide. Domain is a set of all inputs, or the set of all first coordinates, and like we know, first coordinate is x, second coordinate is y, so we can tweak our definition of domain and range to be domain is a set of all x values, and range is a set of all y values. Okay? Let's write this in set notation. If you did not get this, if you did not write it this way, notice how I write it, and then start writing it this way. Domain, set notation. the set of all x's, because that's domain, and this fancy little symbol right here, such that, okay, this thing here means such that, or so that, or when, any of those things. Okay, set of all x's such that, or set of all x's where, okay, it's a conditional. It's not just all x's, it's all the x's when x is what? Well, my smallest x value is a -6. My largest x value is a 0. Question for you. Back here, we had discrete x values. We had 2, 3, and 2. We didn't have 2.1, we didn't have 2.2, we didn't have all the numbers between 2 and 3. We simply had the exact x coordinates, 2, 3, and 2. How about here? Do I only have integer x values, or do I have every single number between all my x values? Meaning, is it discrete or is it continuous? It's continuous. I include every single x coordinate, every single number between a -6 and 0. How do I write that? I want x to be less than or equal to 0, but I also want x to be greater than or equal to -6. I want x to be everything between -6 and 0. Okay? If you didn't write it that way, well, that was a horrible set notation. If you didn't write it that way for the domain, see if you can write it that way for the range. Tweak your range that you had and write it in set notation. What variable are we using? It's not x anymore. The variable is y, the set of all y's where y is what? Smallest y value. There's my smallest y value, 1. There is my largest y value, 4. Largest y value is 4, so y needs to be less than or equal to 4. The smallest y value is a 1, so y needs to be greater than or equal to 1. And there would be my range and domain. And it is a function because it passes the vertical line test. Okay, let's try another one. Actually, I think I've got one. There we go. Domain and range. Use set notation. Domain. Set notation. Set of all x's, where x is what? Smallest x value is 0, largest x is 4. Where x is less than or equal to 4 and greater than or equal to 1. Nope, 0. Okay, so there's my domain. Range, smallest y value is 2. Largest y value is 6. So my range is a set of all y values such that y is less than or equal to 6 and greater than or equal to 2. Hope we're getting the hang of it. Let's try another one. Domain and range. Domain, set of all x's such that what? Smallest x value, way over here at -7. And the largest x value, way over here at 6. Next one, y values, range, smallest y value, -2. Largest y value, 5. Domain and range. Find the smallest x value, find the largest x value, same for the y. All right, we'll stick with that. I don't think we'll get much harder than that. All right, now I need to try one more. I need to show you one more, sorry. I'm rethinking. Domain and range. Let's change this and put arrows on it. What is the domain and range of that guy? Those arrows do mean it goes forever. Okay? Domain. Smallest x value. There isn't one. This arrow says we're going forever. We're going to cover all of, whoops, I'm on eraser still. We're going to cover all of these x values. Everything over here will be covered because there's an arrow. Y values, or sorry, largest x value. There isn't one because it goes forever. Domain is not going to look like that. Domain has no restrictions, so we're simply going to write all real numbers. X can be anything. X will be anything. Okay? Range. Smallest y value, 2. Largest y value, there isn't one. These arrows say go forever. So now it's a set of all y's where y is simply greater than or equal to 2. Don't stop, just go forever. Y is greater than or equal to 2. Okay. Let's try another one of those. I forgot we had to do some where we had things that went forever. Let's do a sideways parabola. How about that guy? Domain and range of that guy. What is the domain and range of that? Domain. Smallest x value. Once again, there isn't a smallest x value. Largest x value. Now there is a largest x value. I did it again. Largest x value at -1. So x has to be what? Greater than a -1 or less than a -1? Less than or equal to a -1. Range. This arrow down here says the y values will go forever in the negative direction. This arrow up here says the y values will go forever in the positive direction. The range, all real numbers. Why do I have to use the word real numbers? Because there is something out there called imaginary numbers. So I do need to use the word real. Can't say all numbers. All real numbers. All right. There's domain and range. Hope that helps. See you next time.